Okay. Alright, I should have. Okay, hold up. Yeah. Okay, now let me go here. Let's see, we want dot game particle. Hey, particle, let's use D dot game. Alright, so we want dot game particle. Right. Dot particle. Their position, frame, and texture. Create a particle with a position, particle render, particle state, texture. Okay. So particle dot, then we have these dots. Particles are just mini animations. What we are going to do is take these animations, spawn them around, spawn them dot to create a trail of colored shimmering particles. Okay. It's a simple particle class. Okay, we have the texture, the position, the frame. Okay. Position of the particle, number of frames, it's live on the screen. The texture has it's self-explanatory. And here the dot with an array of particles and a function to render particle on the dot. Okay. So we have particle array. I want to create included particle. Then I also want a function to render particle. Dot move, dot render, dot render. Okay, we have position and we have velocity and we have these velocities. Then dot create initializes the variable and the event. Separate access tags. Okay, dot move. Then we have void function to dot render particles, and we will take the dot. Also, I want to have an array of particles. So let's create an array of particle particles, and this is total particles. Define total particles 10. We get total. Okay, so total particles. Uninitialized array of particles. Particle. Right. Array of particles, and we define the total number of particles. Then for a particle constructor, we initialize the position around the given position with some randomness to it. We then initialize the frame of the animation with some randomness, so the particle will have a varying life. Finally, we pick the texture. We'll use also pick it at random. Okay. Render particles dot render. Okay. Render particles dot. Okay. Okay, so I want to create these particles, right? We have this function on particle create particle underscore create. It takes to position. We declare particle. Size of particle, and check temp should not be equal to null. We say error fail to create the particle. Then we initialize its position. Sorry, construct position dot x equals whatever x plus, I think, what is some offset -5. Okay, plus RAM, and we mod it with 25. We do the same for y. So we are varying like say I have my dot here, right, and I have my right, so we are already doing we're already doing like say, we're already doing a -5, a 5 by 5 here. Here it's subtracting 5, so it moves up a 5, and then in addition to that we have 5 plus any number from 0 to 24. So that is randomness in position. Then we also provide, okay, so I would need to know the texture. How did I give it texture? The dot, I think its texture is somewhere else. Yeah, texture. Maybe I can, should I store the texture here? I don't think I should store that texture is the dot itself. Texture. I'm like sure because this is G shimmer dot render. Shimmer. Where is the shimmer texture? Do I have the shimmer texture? Shimmer. Oh. Okay. Okay, we replace the texture with shimmer for every 2 frames, I think. Yeah. For every 2 frames, we shimmer the texture. Make texture render. Okay, but I cannot have this, so we'll make few changes. We'll just create an enum particle texture. We'll go with particle red, particle blue, particle green, and what else? There's a particle shimmer, I think. Particle shimmer. Particle. That's it. Okay, and we will store this information here. Particle texture. Let's say p-texture. Then when I render it, we will provide the yeah, since it will be global, I can provide the texture elsewhere. Particle render, right? We have mentioned to render the particle, and you simply, what do we need for rendering? We need the renderer, the texture, and the dot. So let's say renderer, the particle, and since the texture, yeah, see, that is difficult to decide since I don't have the texture, and it defines all in the same file. So how can I let it know the texture beforehand? Particle texture, big texture, it renders, I can fetch that texture. All these texture, then I think I would have to provide I would have to query the particle, and I have to get the texture, I think. Now I have to get the array of textures. obtain the array of texture particle texture, and I think I can use these numbers to simply define the different types of texture in the array. This enough, right? Obtain the array of texture, and depending on the texture type, we render the texture from the texture array. Okay, problem solved. Then I also have to set the temp frame equals 5 if I'm correct. Yeah, initialize animation, provide random position to the particle, provide a random frame time for different life, and then provide a random texture. Provide a random texture to the particle. Right, so we put a switch on mod 3. Okay, 0. Then we have temp dot green texture. I think red, blue, green, and then we have shimmer. Equals to red, brick, blue, green, 1, 2, and that is it, right? Okay. Then we simply return temp, else we return null. Okay, particle read, then we have a particle render. This particle texture array should be of size 4. Right, okay, so we go void particle render. We need the STU renderer and the texture array. Then we have the particle itself. And I forgot. Yeah, no, yeah. Okay. So first we check if invalid particle, right? then I want to how do you render a texture? It must have dot mode of, yeah. Texture underscore render. Yes, sorry. Texture underscore render. We provide the renderer and provide the renderer. Then we provide the texture and we provide the texture. Right, this is an array. I want to provide the address to it. Then we provide the x and y positions and if a clip. And then another for the clip. And that is it. Return. Okay, then we simply return, right? Yeah, fall through. Model position, and then we also have a function to check if the particle is dead. Boom, particle is dead. Particle P. Okay, particle render. Right, and I also have to, I feel like I also have to render the particle. First we render the particle itself. And if number of frames given, we will also render the shimmer texture. So if p frame right, yep, 2 equals 0, yeah, show shimmer. Texture renderer, texture array, shimmer at the same position. And okay, and we increment the number of frames that it has been on the screen. 0p frames plus. Okay. So particle is rendered for a max of 10 frames. We mark it as dead. Okay. So if the particle has persisted for more than 10 frames, If the body is we mark it as dead, so return the frames greater than 10. Alright, okay, now we have to go there and is there anything maybe I can add particle destroy. Let's see. Particle. Hey, free P. P free P. Position. Okay, then we create this new dot. Yeah. Also new. Should I cast it? Well, it doesn't really matter to cast it. Okay, so new dot equals 0. Okay, so first I have to make room for these particles, right? So new dot particles goes calc total particles, size of particle. Particles, collect total particles, size of particle. Then for entire equals 0. Then total particle. I hope I do total particles. Does it know? No, it does not know. Total particles. Yes, total particles. Okay, first I must also check. Fails to allocate the particles. Initialize the particles. Plus particle of particle create, and how does it create? Right. He provided the same x and y coordinate. Okay, and now we can return the dots. Yeah. Is there a dot destroy? No. Okay. Dot The particle render takes a single particle. Okay, I have a dot destroy, so destroy the particle. Dot particles. We go. And that equals less than total particles plus plus, right? There you go. Particle destroy. And the end we go. No, I have simply borrowed the memory. Particles on a dot, then we free dot. And G total windows. Yeah, not happening. Okay, we'll change that. We don't need window, we just need a window. And we'll simply check our window. And all the window events. Yeah. Not happening. All windows closed. It's true. Shown. Quit equals true. Yeah. Won't be doing that. Yeah, we will render. But only a single window. Render the window. Then we destroy our window. Yeah. Okay. Window render that all. Okay. So we destroy this. Okay. Okay, so far so good. you have created, you have deleted, dots rendering that particles are dead and replaces them. Okay, so you have render particles, and in the render particles we check if you destroy the particle, okay, and we create a new particle if they are dead, right? Okay, and then we simply okay, so we render that after rendering the dot we will render the particles. So we go with the function called render particles, and I think I have to make use of this new window. Okay, we have a window and a renderer. And how does window render works? Update caption. Okay, window focus, window render. Okay. So this this is the place where the rendering takes place, right? So don't you draw the window if it is not minimized. Okay. And here is our game logic, right? With the window. So I have a global window, and in the render section I want to render, right? How can I render to a window? How can I render to a window? Okay, first after running we render the particles. So render and particles, they know about the texture, that will be the global texture. Or do I need to provide it? Because when I will, I feel like I do have to provide the texture array. Texture array. Texture array, okay. So yeah, so we go dot renderer This will go available. I say dot texture, and then we take another texture, particle texture. Texture array. Call it texture array. Then we render these particles. Render texture array and the dot itself. Okay, now that is all right, and we render the texture. Render the particles as we want them on top. So let's define dot and particles, right, and particle. So renderer and the dot itself. Let's check dot not equal to and dot. Then we want to go through each of the particles and check. Okay. We'll go through each of the particles. Check if it's that particles set it's that. Try it and create a new one. Let's try. Then dot is the position. y, right? And last we display all the particles. So नहीं उधर है बच्चों के पास. render texture array and particle P. Renderer. And particle. Hmm. 2:10. Fall through. Okay, and with this we are done. Yeah, you have to load the textures. Okay, let's load the textures. We have a window, we have a screen width, font quit, texture dot texture, let's let's load media. How do you load a texture? I have completely forgotten. How do I load a texture? Okay, texture loading. Texture load from file. Okay. I don't have a renderer. No, I do have a renderer. This window does provide a renderer. Right. And I can directly access it. I hope. Yeah. Renderer. Window ID. Multiple window events. I think this would have been a much shorter and smaller window. I feel, yeah, but no renderer. Okay, so it creates a different renderer, right? I think I should use this one. Width, size, though it has more features. Size changed. Okay. STL, okay, so texture load from file. So we go texture load from texture load from file. Okay. File. We taking the renderer, right? I have a G Windows. Let's say G. Yeah. Right. Replace. Okay. So we go G window renderer. Then we need the texture itself. Texture is a dot texture. And the file path, right? So the file path here assets slash dot pmp. I think that's how you I tried to pull failed to load the picture. Okay. Red. What is it called? Red.pmp. Red.pmp. Green. Blue. Finally we have the shimmer. That's shimmer, right? Shimmer. Shimmer.pmp. Let's just try and load it, and then we'll see if it works. Okay. Texture array. Yeah, okay. Texture. Non-type. Particle texture p texture particle.h. Sorry. And then we have .c 91. Texture array. Okay. And F so and 118. Next error. Start particles comparison. Yeah. Let's try assignment. Assignment to expression of the array type. Okay, so I have, okay, sorry. I've already created this on the stack, so I don't need to do this. And okay. See, okay. Undeclared, of course, because game.h doesn't know dot h, and dot h has particle dot h, and particle dot h has particle texture, right? Okay, p frame, yeah, sorry. But let's see. Clear, let me make it again. And show me an empty window. Great. Okay. So far so good. I'm going to create this, and in the actual window. Oh, okay. Window caption, window title. I should be able to provide the title there, but okay. Let's see. Particle. Right. Clear. Make. Yeah. Let's see on tutorial. Update caption. Handle events. I want to disable updating the caption. Let's update caption. Caption update flag. Get rid of this. Okay. And caption, update caption. And we don't have another. Yeah, right. Okay. Particle engine, yeah. Okay, so I'm almost there, and then we set the textures alpha to trans. Okay. Make the textures a little translucent. I should attach texture set form. Okay, so we are here. Just set file texture 192. Then we red, blue, green, red, green, blue, and then we have shimmer. Okay, great. Okay. Render window. Can I do so? Extern white render window. Then provided a definition in the game.c file. Sorry, I have to copy this function, paste it here. The function definition is done here. So I've defined a function, white render. Let's see if that works. And it works. Well, okay. We declare this function external. That is its definition. External window.h file. That means definition will be defined somewhere else. Okay. Possibly other facts. Okay. So what I want to do is, okay, first of all, let's create the dot. We'll delete the dot, right? We have created the dot. That is how you create dot. Then I also have to handle its events. Handle event. Okay, so let's just take the one. So I can go. Handle all window events. Dot events. Does it check for the window? It isn't. No, right? No. Okay, so I need the dot in the event itself. Dot handle events. Then we need to move the dot. Move. Okay. Date. And I have to provide the screen width and the screen height. Okay, there we go. And finally we render the dot. I'm passing the memory address. Alright, won't take the memory address. Easy as that. Okay. Particle render. So texture array. I'm passing an array. I'm passing the whole array. Yeah, not the address to the array. Then we need the address of the texture at that array. Okay. dot c dot render. We got renderer, texture, and dot texture. Then I have texture array. And then we pass on the dot. Let's try and see screen. Dot handle events and defined reference to dot handle events. Dot handle events. Okay. And everything else is okay. Let's reduce the speed. Let us reduce the speed of a dot. Oh, nice. Great.